Ollie mate, happy birthday. I thought I'd make you a YouTube video about, well, it's chapter 1, isn't it? About, here it is, Boolean algebra to Karnaugh maps. All about set theory, essentially, and how Karnaugh maps are probably the most advanced form of representing different kinds of sets. We're going to start with chapter 1, which is binary notation and states. I'm going to have to whip through this because this is now take number 7, and frankly it's bloody awful that I've taken this number of takes to try and shrink this video down to 10 minutes. Okay, so let's go straight on with it. What we're going to do to start with, one thing I should mention is I'm going to use like Microsoft Office, PowerPoint and Excel and things like that to represent what I mean, but and what I do on it is completely incidental. It's just a tool to show you what I mean. So the first thing we're going to do is we are going to start off with 3 different colours: red, blue and green, which are the scientific primary colours, and turn on and off these colours in a kind of binary 1 or 0 type state to then produce 8 other colours. So let's at least get straight on with that and try and represent, to begin with, red, blue, and green. Okay, so if we turn on red and blue together whilst leaving green off, we can get colour, right, what is it? Red and blue, turn off green. Ignore what it says about 255, it's not important, just imagine that 255 is on. So that is cyan, perhaps? Looks cyanish to me. Now let's try turning on blue and green, i.e. turning off red. Set that back down to 0. Maybe that's cyan. I think that's magenta, that's cyan. And then the other combination is red and green turned on, i.e. blue turned off. Well, we're going to get yellow. So I'm just going to go straight for that and go for yellow. Yellow, magenta, and cyan. So let's try and put this into a little table here. I'm going to put R, B, and G up here, and we're going to represent colours down here. So why don't we start with the purely red, blue, and green. So it's just the primary colours essentially. So let's also colour these in for a bit of a laugh. Red, blue, and green. So what do they look like in terms of turning them on and off? Put a 1 there for red being turned on, and so red can be represented by 1, 0, and 0, turning blue and green off. And the same can be said of blue, but obviously just turning on the blue component, and you can probably guess that that's what green looks like. Let's go for yellow. Right, let's start again. Yellow, which, what did I say, was green and red turned on. That one turned on and that one turned on, and blue turned off. Magenta, red and blue, 1 and 0, and cyan, the last one. 0, 1, and 1. As an aside, in paper, when you're reading a newspaper, they use these 8 colours essentially, and only 6 of which you can see at the moment. So you might actually kind of recognise these being printed in the corner as well. And you also, the other thing you'll notice printed in the corner of newspapers as a print and colour test, you could also see white, which is all the colours turned on, which you might remember from your art days, and also black as well. Which is all the colours turned off, i.e. a complete lack of colours. Let's move on to the notation side of this, where we can, other than just simply putting 1s and 0s into this grid, we can also represent it by saying let's copy that, put that there. That red is red turned on, and blue and green turned off, and turned off is notated by a bar above it. Actually, this bar above actually means not. So what you can read this as is red, not blue, not green. And let's fill in the rest of this grid as well. So blue can be represented as not red, blue, and green. This needs to not be a beta symbol, but just a regular symbol there. Green can be represented as not green, blue. That's totally wrong. Green can be represented as not red, not blue, and green. Not as a gamma symbol, but instead it's that. And yellow. Okay, so these are the primary colours here, essentially spelt out in the notation. Yellow can be represented as red and green, but not blue. Red, green, not blue. Magenta as red and blue, not green. Yep. Cyan as not red, blue, and green. And white as all of these turned on, red, blue, and green. Whilst black is a lack of any colour. Red as not red, not blue, and not green. And the third thing about this is the state. Right, you can change from, say, yellow to green by simply, so the state of yellow, the yellow state, to the green state. The colour can be changed from a yellow state to a green state simply by turning off the red component. So if you want to transist between yellow and green, you turn off the red state. So red gets turned off there, and you can see that not marked there, and these other two components stay the same. And that's pretty much all I have to say about state. The next thing we're going to be moving on to is a Venn diagram, but let me stop the video there so that chapter 1 is complete.